Hi everyone, thanks for joining today. My name is Wolfgang Pauli and I'm joined by Dr. Mario Nkyosa in San Francisco to talk about a couple of interesting AI and machine learning projects that we have worked on in the last couple months. Mario and I are both on the ACE team. We are part of the Microsoft AI Platform Engineering organization, and our team is in charge of testing the envelope a little bit, pushing the envelope a little bit on AI and machine learning, both in terms of what can be done with AI and machine learning, and then also in discovering new domains in which to apply it in new ways. In that role, we are also supporting the product development in our organization to make sure we build better services and tools for data scientists and software developers. Here's the agenda for today. I want to start by talking about a project that had the goal to detect illegal wildlife trafficking at London Heathrow Airport. Then I want to talk about a project with Ernst & Young Global Limited, where we're building a custom search engine for internal use that is endowed with the ability to understand natural language. Then Mario wants to talk about a project where he built a COVID-19 bot. After that, we'll switch gears a little bit to the retail space, where our team built a forecasting engine to predict COVID-related employee absenteeism. And then Mario wants to close out on a project that has the goal to assess and mitigate the unfairness in financial applications at EY. So let's get right to it. Let's look at this project where we partner with London Heathrow Airport to detect illegal wildlife trafficking. This project was supported by the Microsoft AI for Earth program, and the goal was to really reduce the amount of trafficking because it turns out it's a global multi-billion-dollar industry. To understand the scale of this problem, just look at the room here that contains the confiscated items at London Heathrow Airport. It's a really sad collection of diverse items, from elephant tusks to skulls of various endangered reptiles and birds, including some items that are considered to have medicinal advantages or are considered a delicacy in certain countries. Because these items are really difficult to detect with manual X-ray screenings, the only chance that UK Border Force currently has is to profile passengers based on their origin and their flight patterns to search their bags manually. And you can probably think of at least two reasons why this is a bad idea or a bad solution. First, the passengers might find this unfair, that their bags are constantly being screened just because of the country that they're coming from or flying to. And second, quite frankly, it doesn't work very well because this way we're only catching around 10% or so of the trafficked items. So let's take a look at how the solution works. As a bag goes through the scanner, it creates a 3D VTK file. VTK is an open source data format that is commonly used in hospitals for CT scans. These files are around 50 megabytes large, sometimes larger. They are stored on the scanner locally, but then we transfer them onto an Azure Stack Edge device, which allows us to perform this inferencing locally, so it's robust against network outages and also reduces the amount of traffic of data that needs to be uploaded to Azure. There are several modules running on this Azure Stack Edge device. One is a sync module that copies the files from the scanner onto the Azure Stack Edge device. Then we have a pre-processing module that rotates the bag so we can look at it from different angles, and it filters out the items that we're not interested in, such as high-density items like metal, or really low-density items that are much lighter than bone, so that all that is left in the suitcase is something that has about the particle density of bone. We then have the AI module look at the shape of the object that is left in the suitcase to identify whether this is, in fact, an item that we need to flag or whether it's something harmless, like a China vase, that has a similar particle density, but it's just not something that needs to be flagged. Then we have the broker module, which manages the communication among the different devices. So at the end, the verdict of the model is written to an output folder, which is constantly being synced with Azure Blob Storage, where we have an Azure Logic app that processes the output from the model, which is in JSON format, to populate a SQL database that we can then connect to a Power App, which allows the border agents to review the results of the model processing to then either decide that a bag needs to manually be searched, or to say the AI model incorrectly identified as something illegal in here, and because of that, we want to add that to the training set so that the model does a better job next time. I hope you understand that I cannot really talk in great detail of how the AI model works. We are in a constant tug of war with traffickers, such that they're constantly inventing new ways of hiding objects in the suitcase, while we are trying to constantly improve our model and our chance of detecting these items. In addition to that, we're also getting word from these border agents about new items being trafficked. So we have to respond very quickly to emergent trends in the trafficking business. So because of that, we have to constantly retrain our models, constantly improve them. And that's what I can show you now. How do we get these models back on the edge device so the edge devices at the airports are always up to date with the newest technology of what can be done in this space. In order to do this, I'm going to switch to VS Code. So here in VS Code, I can show you how to do this manually. In reality, of course, as we have this in production now, we have a release pipeline so that whenever a new model is registered in the Azure Machine Learning Workspace, it triggers a release pipeline that automatically updates the Azure Stack Edge device. But here I can show you how this would be done manually. So we would use the Azure IoT Edge extension for VS Code. The first step would be to build and push the IoT Edge solution. We select the template that defines in JSON format what the different containers are that need to be running on the edge device and how they talk to each other. We then start the build process, and you see that it's running rather quickly. So this builds all the containers, but it does it incrementally. Only the containers that need to be changed will be built again. And even within the containers that are updated, we only update the layers that need to be updated. We only updating the AI model at this point, so there's really just one layer, and that's why we see the layer already exists messages here, because nothing has to be done for all these layers because they're already up to date. Once you're done with this step, we want to actually deploy the new solution to a single device. So in this step, we first select the device that we want to deploy to. We select the deployment manifest that was created in this previous step, and you see that it runs almost instantly because all it does is notify the IoT hub of a new deployment manifest so that it knows which containers to send to which edge device. We can now go into the IoT hub to see whether everything has gone as expected. For this purpose, we will go into the Azure portal. We will look at our device, and here we can see that all the containers are running as expected on this device. We can also see that the edge agent is running, which is of course really important because it allows us to manage this edge device remotely. So at least that one should be running. Now that we know that everything is running on the module, we can actually look at what is happening under the hood. For the purposes of this demo, I can SSH into the edge device. Normally you wouldn't be able to do that for security purposes, but I can do it today. First step is we can look at the log file of the edge agent, and we can see that it has restarted all the modules because they have been updated. Then we can look at the log file of the pre-processing module. So what we can see there is that it's getting these new files from the scanner. Yep, and then you can see how it renders images from different angles so that we can send these various images from different perspectives to the AI model for scoring. And here you see the output from the AI model. So you can see that for each of the frame, it makes a certain prediction, whether it can see something in it. And it gives it a probability, what kind of object it found, and the coordinates of the bounding box around it. Like I said, the output of the model is then synced to Azure Blob Storage. So we have this Azure Logic app here, which parses the JSON data that has been uploaded and then inserts it into a SQL database, which is connected to a Power App, which I happen to have on my phone here. So I can review what is going on over there, see what the model has found. And now I could either say this is incorrect and add it to the training set to retrain the model so it doesn't make the same mistake again. Or I can ask someone to search a bag manually just to make sure, because the model thinks there's something in it. Like I said, this is a constant back and forth. We are continuously improving the model, but so far it's looking pretty good. Let's switch gears a little bit. Another project that I want to talk about is a project where we built a custom search engine for internal use for Ernst & Young, where they wanted to have a search engine that is only for internal use on their personal data. They wanted to have it for two reasons. One is to allow their employees to search the sensitive information, which is of course not public, and so for that reason you cannot use a public search engine. And secondly, they wanted to have access to the log files of their searches so that they continuously can improve the results of their search engine. So what do I actually mean when I say search with natural language understanding? You might still be using a search engine in the old way, where we just provide a couple of keywords and you hope that you get a page where you have a high frequency of these words occurring in the text. Modern search engines like Bing can do much more than that. They understand what the intent of the user is. So when I type in Azure, what is Azure Machine Learning Services? The search engine understands that I'm actually looking for something in particular, that I'm not just looking for pages where these keywords appear. They understand that I'm looking for our platform, Azure Machine Learning Services, right? And that's basically what EY wants as well. They don't just want to have a search engine where their employees can type in keywords. They want to have a search engine that understands what the employee is looking for. And you can build this with two Azure tools quite quickly. On the one hand, you have Azure Cognitive Search, which you might already be familiar with. It allows you to have this traditional experience where you have a search index, and using keywords, you can look something up in the search index. What you can do then is add LUIS, which is our product for natural language understanding, which allows to understand what the user actually wants and what the intent is. So basically, what LUIS does, it converts a free text query like find AI startups in Los Angeles into output where you have the intent of the user identified, which is to find startups, and also to extract the entities, which in this case is the industry that the user is interested in, which is artificial intelligence, and also the location that the user is interested in, which is Los Angeles. LUIS does all of that, and it has a couple of things going on under the hood. On the one hand, it has a deterministic parser. On the other hand, it has classification and extraction modules for intent classification and entity extraction. Then on the output side, it performs entity resolution, because sometimes there's more than one interpretation of what the user actually wants given a sentence. And so this entity resolution mechanism takes the various constraints and findings into account to evaluate what is the most likely intent of the user at this point. So this is all happening in LUIS. So far it looks pretty simple, but trust me, you can be glad that LUIS exists, because what's going on under the hood is quite complicated. And the team has done a really good job making sure that these items work well together. For example, you won't have to train your own support vector machines anymore and do your own hyperparameter tuning and do model selection afterwards. And you won't even have to learn what conditional random fields are. Maybe you never wanted to know that anyways. The second reason that EY wanted to have this custom-built search engine is they wanted to be in control of improving the performance of the search engine. How can you do that? One approach here, and I'm using an example from a retail space, is that you can store the search queries and what the user went for in the end to update your data set. So for example, here, the search query could have been any blue bathroom tiles. We then see what the customer actually ordered. And because we maintain the product database, we know what attributes are associated with each of these products. So for example, we know that these tiles that were ordered were blue, and we know that they were square, which means that we can now automatically annotate the search query and highlight the entities. And now that we have this annotated additional data, we can go back to Lewis and retrain it so that next time around, it has an even better understanding of the search queries as they occur. Yeah, so that was that. I'll pass the mic on to Mario, who wants to talk about another project that involves Lewis, but it's a completely different use case. So Mario, over to you.
Thanks, Wolfgang. Now let's discuss two COVID-related use cases. The first use case is a virtual assistant for EY's healthcare clients. Starting in 2019, Microsoft and EY engaged to create an intelligent customer care virtual assistant platform. It runs as a service in Azure, and it's targeted at specific industries which originally did not include healthcare. However, COVID-19 hit, and EY's clients were scrambling to provide information related to benefits, COVID testing, scheduling appointments, mental health, well-being, and FAQs. To address this need, the virtual assistant work was rapidly transitioned to a new industry and use case, the virtual assistant for hospitals. Within weeks, EY had an AI-enabled COVID bot ready for their healthcare clients. Now let's take a look at the architecture. We start with Azure Bot Service. Then we add Microsoft AI services. The QAMaker is used to rapidly create knowledge bases from documents. The QAMaker was key in rapidly creating a bot with COVID domain knowledge. Lewis, for language understanding, allows users to vary the way in which they ask a question to the bot. If the user enters personally identifiable information, Content Moderator will recognize that and mask it. The architecture also includes Azure App Services for the Virtual Agent Controller and the Virtual Agent Gateway, as well as table storage for session state, App Insights for the log, and Power BI for analytics. This bot implements a multi-turn dialog flow. It can begin by asking the user their language preference, then asking the user if they would prefer to browse an FAQ or assess symptoms. If they wish to browse the FAQ, they're presented with topics and subtopics. If they wish to assess symptoms, the bot asks them about their COVID symptoms, as well as pre-existing conditions, and using multi-turn dialog flow gives them a recommendation based on the answers to those two questions. Now let's try out QAMaker and see how this works. I started by creating a simple Word document with headings and subheadings to capture the knowledge. Then I ingested this Word document into QAMaker, and QAMaker turned it into a knowledge base with context, questions, and answers. We can test it out right in QAMaker. QAMaker will start by telling us our options. We can choose a category or type in a question. So I will choose the Assess Symptoms category. It asks me about my symptoms. I can reply to that. It asks me about pre-existing conditions. If I say yes to that as well, it will give me advice to contact the hospital as soon as possible. Now let's try typing in a question. Say, when can I get a test? We find that testing is offered 24 hours a day. And note that there were very few words in common between the question and the answer, but the Lewis service was able to determine that this question was highly related to this answer in the FAQ. Now let's go on to our second use case. Our next use case is also COVID-related, specifically forecasting absenteeism due to COVID, which could result in a labor shortage. The customer had a forecasting model, but urgently wanted to know if prediction quality could be improved, so this required a very rapid response. We started by ingesting the data into Azure Blob Storage, and then running automated machine learning. Azure Machine Learning includes a capability called automated machine learning that can explore many models and specifically includes models tuned for forecasting. These include the profit model, the auto-ARIMA algorithm, and the forecast TCN algorithm, which is a deep learning algorithm. TCN stands for temporal convolutional networks. Many other traditional machine learning algorithms that are not specific to forecasting are also explored. The automated machine learning tries these algorithms with many combinations of parameters, and that's a process called hyperparameter tuning. After having explored hundreds or thousands of models, the AutoML returns the best model found. This can then be validated and deployed. In our case, within a day, we had found a model that predicted approximately 25% better, and the customer was thrilled. So after validating, they decided to rapidly deploy this to over 2,000 locations. So let's take a look at a quick demo of automated machine learning. We'll start out in the Azure Machine Learning Studio, and to create a new automated ML run, we can go on to create new automated ML run. We select a data set. In this case, the beer data set, which is a sample data set of beer production. Then we go ahead and choose an experiment name, a target column, the column we were trying to predict, which is beer production, and a cluster. This automated machine learning can use compute clusters, so many models can be explored in parallel for greatly speeding up the process and using the power of the cloud. Finally, we select the task type, which is time series forecasting, and we have to specify the time column. It's called date in this data set. And we optionally enable deep learning so that we can use that forecast TCN algorithm. Now, this is a wizard-based approach, but there's also a code-based approach, so this can all be scripted in Python, for example. And let's see what we get when the automated ML completes. We'll get an accounting, a list of the algorithms explored and the performance of those algorithms. In this case, this is an error measure, so the smaller the error, the better. The best algorithm is listed here at the top. It is the TCN forecaster algorithm. We can select that algorithm and we can even deploy it right here from the studio. Now let's move on to our last customer use case, assessing and mitigating unfairness in AI systems. This is a collaboration between Azure, Microsoft Research, and EY. Azure Machine Learning supports responsible machine learning in a variety of ways. It allows you to deeply understand your models by providing rich support for the InterpretML package, and it allows you to assess and mitigate unfairness via the FairLearn package. It allows you to protect sensitive data via differential privacy, encryption, and secure environments, and it allows you to control your machine learning models using lineage and audit trails that meet regulatory requirements. Let's jump right to the punchline of this use case. EY trusts the Azure AI platform because it allows interpretability of ML models, and it provides capabilities to assess and mitigate unfairness to help EY's customers and regulators. Using FairLearn, EY found they could reduce the disparity of loan approval between men and women by 7% without impacting costs. They did this using FairLearn, an open source package integrated with Azure Machine Learning Studio. FairLearn focuses on assessing and mitigating negative impact on groups. That impact can be measured in a couple of ways or can arise in a couple of ways. One example is quality of service impact. For example, imagine a voice recognition system that works better with some groups than others. Another example would be an allocation impact. which is closer to our use case here with EY. For example, a use case where a loan screening system provides a different answer, provides basically impacts some groups versus others and negatively. Not only does the Fair Learn package assess unfairness, it also mitigates unfairness by providing a variety of algorithms. These algorithms can be used either during training or they can be used with already existing models after training. Now, fairness and performance tend to be in tension with each other to some extent, so there's a trade-off. FairLearn allows you to optimize this trade-off between fairness and performance. Now let's go to a demo to see how this actually works. I'm going to go to the Azure Machine Learning Studio, and I will bring up my experiments. This is our audit trail of runs we've done. I'll go with my most recent experiment and the most recent run. And we can see here for this run, we have a tab labeled Fairness. So let's click into the Fairness tab to understand the fairness of our model. Now this model is similar to the EY model. It's not using the EY data, but you can also imagine it as a model that predicts whether someone should be given a loan. Now the first thing we see is we get to choose between sensitive features, such as race and sex. In this case, let's choose sex to see how the model treats men versus women. Now the model suggests several performance measures we may want to consider. We can go with the suggested one here, accuracy. And we now see how our model may differ in its treatment of different groups. This first plot is a plot of disparity in performance. It says that overall, the model is fairly accurate, 83%, but there's a 12% disparity in accuracy. Specifically, it turns out that women are actually judged much more accurately by the model. Its predictions are much more accurate, 92% accurate, but its predictions are only 79% accurate for men. So interesting. But even more relevant here is the so-called selection rate. So this is how many people are actually approved for a loan by the model if it were used. So it turns out there's an 18% disparity in the selection rate, and the model is giving loans to a much smaller percentage of women, only 5% females versus 23% of males get a loan. So this is a big disparity. What can we do about it? Well, we can use the FairLearn package. I have another run here where I've used FairLearn's grid search algorithm. What this does is it will try to find a better trade-off between disparity and accuracy. In this plot, we see disparity on the vertical axis. We want the disparity to be as low as possible. And we see model accuracy on the horizontal axis. We want accuracy to be as high as possible. So if we look at the dot in the upper left-hand corner, which has the worst disparity but the best accuracy, that's our original unmitigated model. We also see that FairLearn has found another model with virtually the same accuracy but a significantly lower disparity. Additionally, there are several additional models that give us different points trading off disparity versus accuracy. This one on the lower left has very low disparity, and given the very fine scale here on accuracy, it's actually giving a pretty close accuracy to the original accuracy as well. So that would be a good trade-off. But depending on the use case, one could select any of these models. So that brings us to the end of our last use case. I'll share these URLs if you'd like to learn more. And of course, you can email our team at aace@microsoft.com. Thank you.